Hi, this is Janak Reddy Dubaka. Neet physics quick revision, that is formula revision. In this lecture, we are going to discuss center of mass part 2. See here, center of mass of continuous mass distribution. Here, center of mass of some common rigid bodies. This is semicircular ring. Therefore, its center of mass from the base, that is 2r by pi. And this is semicircular disk, that is 4r by 3 pi. And hemispherical shell, this is r by 2. Solid hemisphere, 3r by 8. This is solid cone. From the base, it is h by 4. So in some problem may ask from the vertex also. So here, from the vertex, this distance, total height h, this is h by 4. H minus h by 4, this is 3h by 4. Like this, hollow cone, here it is h by 3. And from vertex, total height h minus h by 3, that is 3h by 3. So 2h by 3. This is 2h by 3. These are the center of mass of some rigid bodies. See, center of mass of group of objects. See here, here is one object. It may be disk or anything. First, we have to locate its center of mass C1. And its center of mass position vector is R1 bar. Here is another object is given and its center of mass is C2 and its position vector is R2 bar. Like that, here one sphere is given, its center of mass C3, therefore its position vector is R3 bar. Then for this group of object, RC bar is equal to M1 R1 bar plus M2 R2 bar plus M3 R3 bar by M1 plus M2 plus M3. For example, group of laminar type bodies means two-dimensional bodies. For two-dimensional bodies, for example, if two bodies are given, in that case, if you know the area, RC bar is equal to thickness is negligible. Therefore, here A1 R1 bar plus A2 R2 bar by A1 plus A2. This is a center of mass of group of objects. Next one, center of mass of an object with removed mass. With a removed mass, it's a very, very important one. X, Y. For example, here is the original mass object. Its mass is M1. First, we have to locate the center of mass of this original object C1. Therefore, its position vector of center of mass is R1 bar. From this, we removed some mass M2. Therefore, removed mass center of mass is C2. Its position vector is R2 bar. Then RC bar is equal to M1 R1 bar minus M2 R2 bar. Here mass M2 is removed. Therefore, M1 minus M2. If you know the area, then RC bar is equal to M1 RC bar is equal to A1 R1 bar minus A2 R2 bar by A1 minus A2. See, based on this, here is one problem. A uniform metal disc of radius r is taken and out of it a disc of diameter r, therefore radius r by 2 is cut off from the end. The center of mass of the remaining part will be. See here, first here step 1. In step 1, we have to find out first one area of the original disc and the area of the removed disc. A1 is equal to area A1 is equal to pi r square. And the area of the removed part pi into radius r by 2 whole square. This becomes pi r square by 4. And in step 2, we have to locate the coordinates of center of mass. First, original disk center of mass we have to consider at the origin. It is very easy. Then x2 y2 is equal to 0 comma 0. Then coordinates of center of mass removed part. This is C1, this is C2. For removed parts coordinates, this is x1 y1. So here x1 y1 is equal to 0 comma 0. Then x2 y2, these are the coordinates of removed part. This is the removed part. Here center of mass is this one. This distance from the origin, that is r by 2. Therefore r by 2 comma 0. R by 2 comma 0. Therefore their center of mass along x-axis only one coordinate, that is xc. That is step 3. Step 3 we have to use the formula, that is xc is equal to a1 x1 minus a2 x2 by a1 minus a2. a1 is pi r square into 0. a2 means pi r square by 4. x2 means r by 2 by pi r square minus pi r square by 4. Therefore xc is equal to, this becomes minus pi r square pi r cube minus pi r cube by 8 into, here this becomes pi r square minus pi r square by 4, pi r square common. So I am writing another step here, minus pi r cube by 8. Here pi r square common. This becomes 1 minus 1 by 4. 4 minus 3 by 4. Therefore 4 by 3 pi r square. Therefore here pi r square, 1 pi r square cancel. 4 2 times. This becomes minus r by 6. See, minus r by 6 means, therefore the center of mass of this original disk shifted towards right. Therefore here shift in center of mass, originally it is a C1, it is shifted to, for example, C3. This is x, that x is equal to minus r by 6. Next one, another problem. Here a uniform circular disc has radius r. A square portion of diagonal r is cut out from it. The center of mass of the remaining portion. See, this is the uniform circular disc of radius r. Takes capital R. And here the diagonal is r. Therefore step 1, in step 1 I have to find out the area of the original disk a1, that is equal to pi r square. Area of the removed part, here a square is removed, this is the square of diagonal r is given, therefore this side is r by 2. Therefore square of side r by 2, area a square means r by root 2 whole square. Therefore this is r by root 2 whole square. This becomes r square by 2. This is step 1. In step 2, I have to locate the center of mass of the original. See, original disk center of mass is C1 and removed part center of mass is C2. Therefore, original disk center is at origin. Therefore, x1 comma y1 is equal to 0 comma 0 and the removed part x2 comma y2, that is equal to, here the total The total distance is r. Therefore, this becomes r by 2. Therefore, here r by 2 comma 0. Then step 3. Step 3, we have to use the formula xc is equal to a1 x1 minus a2 x2 by a1 minus a2. a1 means pi r square. This is 0. Minus a2 means r square by 2 into x2 r by 2 by pi r square minus r square by 2. After simplification, we can get the answer. This is r by 2 minus 4 pi. This is center of mass of the remaining part. See, like this, this is very, very important. We have to find out the when some mass is removed or some portion is removed, what is the shift inside or locate the center of mass of the remaining part. Any problem, step 1, we have to find out the given area of the original body and the area of the removed part. And in step 2, I have to find out the coordinates of original body and the coordinates of the removed part. In step 3, you have to use the formula, that is a1 x1 minus a2 x2 by a1 minus a2. This is part 2, center of mass.